All right, how many of you have heard of CoreOS? Now give me a ooh. I actually told my wife I was going to do that, so that's why I did it. So I have worked at a few companies. Worked at Backcountry, they're up in Park City. Beyond Oblivion, they no longer exist. Space Monkey, they're at Vivint now. Weaver State is where I graduated from. And I now work for Gaia GPS. We do map, yeah, bleed purple. Now I work at Gaia GPS. We do map applications for mobile devices, for hikers and four-wheelers and Jeep guys and, I don't know, people searching for gold out in Vegas. True story. These are two pretty famous people that I don't know their names, so I tried it down. Adrian Ballinger and Emily Harrington. They summited Everest, and they used an iPad and Gaia GPS to get to the top, which is pretty awesome. It was really cool for us. Apple featured us in their, I think they called it their Uverse promo, so we were on the front page of Apple last year. That was really cool. We also do a few other map applications. We do contracting for a company called HEMA Maps. That's an Australian company for off-roading. We do their application. We do a Skipper, which is for boating, kind of same deal, that map navigation. We also did a Burning Man app for a couple of years that everybody used. There's 2 founders, 2 full-time programmers, and 3 support people. So we only have 7 employees. We're scattered all around the country. Yeah, that's it. So 7 employees, and last year we had 4 babies.
Wow. What's in the water?
Yeah, and the 2 founders are husband and wife, so that's even better. So it is kind of relevant to the talk, though, and that's that we had quite a bit of infrastructure that we have to maintain, but we don't have a lot of time. This is kind of a high level of what our infrastructure looked like before we migrated to CoreOS, and I guess kind of after, just because it's so vague. But really, we have 2 different data centers, or 2 different AWS regions. In the US one, we host Skipper and Gaia GPS, and in Australia we host HEMA Maps. They're basically clones of infrastructure, other than we're actually hosting 2 different applications, just white labeled for different for the different brands. So we, even though we're small, we still have quite a bit of infrastructure. And so before we went to CoreOS, we were looking at our infrastructure. We're one of the only map software where you can sync with the cloud, and we have our own cloud built, and our own cloud service, I guess, not our own cloud. And we had a lot of infrastructure to maintain, and we had just a lot of random services everywhere on different boxes. Configuration was a pain. We have 3 different places that we need configuration. That was all modified by hand, and it was a mess. And so we were looking at something to help with that. And I had quite a bit of Docker experience, nothing in production yet, and CoreOS was still brand new. This was sometime last. I think we've been doing it close to a year, probably about 9 months. So CoreOS was still brand new. How we started down the road of CoreOS was, it was new and in the news. And I was like, that's cool. And so I just started working with it, and things were working well. So we're like, okay, we'll keep doing it. And here we are in production, making lots of changes, and we have lots more plans for it as well. So we're kind of iterating on it. But when we were sat down to do it, we had to get some goals. And this was our goals. No, I'm just kidding. Our main goals were we have a minimal team, and we want to be able to do minimal maintenance. Most of our users interact with us not through the website, but through the devices. And so we needed to make sure that the sync was working 100% well. And we just didn't want to spend the time maintaining this infrastructure. So but we also didn't have the budget for using something like Heroku with all our different services. Because if you have a microservices architecture with Heroku, all those computes can add up. We also wanted a little more uptime. Some of our services just had one box. So it means it went down, then a whole portion of our service went down. We wanted it to be simple, and we wanted it to be secure. So that's where Docker came in. So who actually doesn't know about Docker? I won't make you do the woo woo again. Okay, raise your hands again. Sorry. Okay, a couple of you. So I'll go over Docker briefly, but Docker is just basically VMs. Like, think of it as VMs. I mean, I know it's lighter weight and stuff like that, but it really is just a VM. So why was Docker so popular? Like, LXC and C groups have been around for quite some time, and nobody was really jumping on the bandwagon until Docker gave their demo a couple of years ago, showing how cool it is. But personally, I think one of the big reasons that Docker is catching on so quickly is because of their what do they call it, registry, whatever. Their repository for hosting all of the different images. So you can get a Linux box, or on Mac you can run VirtualBox and run all these different operating systems, and so you can run like a virtual BusyBox really easily. But on top of that, you also have applications, and with those applications you have all your dependencies. So you no longer have to set up a box, install the dependencies on the box, run the application, and then if you have another application that has different dependencies, set up another one. You can just say like Docker run Redis, and your Redis boxes will download automatically and run. So Docker just makes it really, really, really easy to do all this stuff. And so companies are starting to use it for deployments, and it's working really well. Here's an example Docker file. This one's for Redis. Since most of you are familiar, I won't go too deep into it, but basically you specify a base box, you run a set of commands, you can specify volumes, expose ports, and then run an entry point command. I won't give a Docker demo. I'll show you how it works as we're going through CoreOS. So let's jump into CoreOS. First thing you need to know about CoreOS and everything else is that it's kind of a wild west. There's nothing that's really solidified. Things are changing every day. CoreOS just yesterday got $12 million to start working on using Kubernetes, or integrating Kubernetes into CoreOS for enterprise customers. I mean, this is yesterday, right? Like, new things are happening every day. Things are changing really, really fast. And so if you want to get into this, like, you shouldn't expect things to be stable. So on the $12 million announcement on Hacker News yesterday, Kelsey Hightower, he's an employee of CoreOS, he was talking about like where CoreOS have been and where they're going. And he basically said for the last year or so, they've been working on just moving really fast and iterating and chucking things that don't work. And they actually rewrote etcd over the last 9 months. Yeah, so things are moving really fast. CoreOS is trying to stabilize. They think they've found product market fit, and they're moving forward. But I still expect things will change. So the parts of CoreOS, CoreOS is really a minimal operating system. It's just meant for hosting Docker containers and providing a little bit of tools to do that. It also wants to provide reliable updates, which we'll get into. Fast patch. So fast patch is a way of updating the operating system. This isn't a way of updating your Docker containers. It's just the core tools that CoreOS provides, like we'll go into like Fleet and etcd and even Bash. So there's there's 3 different channels that they have: alpha, beta, and stable. If you're in production, you'll want it unstable. FastPatch provides cluster-aware updates. So if you have 3 different nodes of CoreOS, only one will go down at a time to apply these updates. It has atomic updates, so either it works or it doesn't. An update. You can't really be in this inconsistent state of current operating systems. It provides automatic upgrades. One of our core requirements was something that's easy to maintain. Well, if CoreOS does all our updates for us, that's something that we don't have to do. And most of the core operating system is read-only, so you can't get in there and break things. This is the way the active-passive works. So the operating system is A. When an update is found in one of the channels, it'll download it onto partition B and then restart that box, basically like changing the mount point to be B. So then B is the active and A is the passive. Next time it goes around, it'll update the A, and so kind of flip-flops back and forth. If an update fails, it'll recover automatically to be to the old partition, or you can also do that manually. So super easy updates. Part of their enterprise offering, we don't use this, but it looks pretty cool. You can have a UI for managing all your updates and do something a little more advanced for bigger clusters. Another tool that CoreOS provides is etcd, and this is awesome. I think it's probably the most active project that CoreOS has right now. Like I said, they just ended up rewriting it over the last 9 months, and this little diagram. Let's see if it works. Oh, dang it. Well, so etcd uses the RAF consensus protocol. If you saw JT's talk about that. Basically, etcd is a key value store that's distributed through all your nodes. So if you set a key on one node, it is already there on another node. So that's all you need to worry about. It's basically like Zookeeper, if you're familiar with Zookeeper. Also provides things like watching keys and distributed locks. It's used for basically storing configuration information over the cluster, and can also be used for things like leader election and stuff like that. Oh, there we go. Okay. There's the consensus protocol. It's the key part of CoreOS, really. Here's a few of the commands that you can use for running Fleet. So like I say, it's super basic. You ls a root directory. It shows you the children directories, and you can make a key. It sets the key, list what keys are there, and get a key. So just get put. It's really a REST API. Like, you can use curl for all this stuff as well. It's a daemon that runs on the local box, but uses the consensus protocol for distributing the information. Another part is systemd, and there's a lot of drama going on around systemd. Don't yell for me liking it. So systemd is a replacement for init. So basically, it's getting rid of all of your bash scripts for init files and replacing them with a more structured thing, so you can do things like have dependencies really easily. Here's an example of an init script, which is called a unit. This one in particular is a service. So you can specify different environment variables, the things to run before. That's kind of important in just tracking the status, the actual command to run, and things to run after it's started, and also how to stop it, how to stop things. You can also, like I said, specify dependencies, so this will run after Docker is started. It also requires it. After and requires usually go together. Oh, so feel free to ask questions too, by the way. I'm probably skipping a lot. Is that all good? Yeah, okay. So built on top of systemd. Oh, so systemd isn't a CoreOS project, it just uses it. But built on top of CoreOS is Fleet, and that's taking systemd and applying it to a cluster so that rather than logging onto each box individually, you can manage all the services for the entire cluster using one tool and one command. So here is an example of our cluster running a whole bunch of different services. This is spread across a whole bunch of different boxes, and it just lists it. So you can use Fleet to list the units, stop, start, apply. There's no rebalance. The scheduler for Fleet is super simple, super basic, and you can't really change it. And I don't know if you ever will be with Kubernetes coming out. But we use Fleet, and it's worked really well for us. So systemd has some specifiers, or basically like variables that are replaced with your environment as things are running. And Fleet builds on top of it to provide a few different other like cluster-related things. So basically, if in a systemd unit file you add a %n, then it'll be the actual unit name. This is kind of confusing right now. I don't know how to explain it, but it'll become more clear in some examples. But some of the other things that you can use in systemd unit files as an extension with Fleet are assigning the type of machine that it will run on, or say things that are conflicting. So for example, if you have Nginx bound to port 80 and it has to be on port 80, that means you can't run two different Docker containers of Nginx on it. So you say it conflicts with any other service by the name of Nginx, for example. That way the scheduler knows, don't assign two Nginx services to run on the same machine. Yeah, so there's a bunch of different other ones there. And global, that one will run it on all boxes in the cluster. Those are good for things like maintenance, cleaning up, temp files, whatever. All right, so cloud config. This is how you launch services, or launch CoreOS servers. It's a standard that already exists. CoreOS didn't make it; they just use it. So here's an example one. Basically, almost the smallest one that you need for starting a CoreOS server. If you're using EC2, you know the user data that you can pass in to run things right when it's provisioning. This data is used as the user data, and CoreOS knows to parse it and set some config values on it. So one of those that you need is a discovery URL, or so for etc to work is a discovery URL and also some ports, so that etc can communicate with each other, and also where to bind it to and stuff like that. What it uses by default is a hosted service that manages the cluster. So this is kind of the node introductions. When the CoreOS box starts up, it'll ping this URL right here. You create it right here. And it'll ping this URL to figure out how to join the cluster or what nodes it needs to talk to. And then you can also create units, the systemd units, to run on startup. So for example, this one will format the ephemeral storage for EC2. And it'll also start etcd and Fleet services. Sorry, this isn't Go, guys. We use Python. So for config, when running Docker, you saw in the systemd how you can specify the environment file. That's actually what we use for config too. We pass in environment variables into CoreOS, into the Docker containers. And so this is basically what we change the application from. It used to be like a local file called like settingsprod.py, and we'd include the configuration stuff just hard-coded in there. Now we just use environment variables. So Heroku kind of started the whole configuring thing through environment variables, and that's really where the standard is going as well, especially as you're linking Docker containers, if anyone has ever used Docker Compose or something like that. Yeah?
I have a kind of a random question.
Yeah.
You know how the CEO of CoreOS is talking about replacing Docker containers with Rocket?
Yeah.
Does that have any bearing on what you're showing us today?
No.
Do you have an opinion?
I hope Rocket becomes stable. Like, there's some problems with Docker that I don't like. One of it is it's trying to do everything, and there's like no real way to kind of get in and make your own tools out of it, honestly. They're trying to do everything under the sun. Rocket, I think, is cool because it's, you know, they just have the spec, so you can make your own Rocket if you wanted to. I know Docker published theirs as well, but CoreOS is being a little more open. And another thing is that Docker, one thing that really sucks about it for me right now is that it's kind of running as a client and a server. So when you run the Docker command, it's actually a client, which is why you can use VirtualBox with it, but run Docker locally on the Mac. And Rocket doesn't do that. It's a lot more lightweight, doesn't provide as many features, but it's just like straight, this is the command that we're running. So the reason that's a problem is for things like systemd. In systemd, you say start this script, right? And then systemd will manage it. So what you do is you say Docker run this image, and it will it'll run the image. But what systemd is actually tracking is the client. So if the client terminates for whatever reason, whatever problem, but the container can still be running in Docker. So Rocket will kind of get past that. So yeah, I'm excited to see what Rocket does. I actually have a commit in there I'm super proud of. I changed the hashing of images from SHA-256 to SHA-512. Because SHA-512 is faster on 64-bit computers. So yeah. Anyway, yeah, I like Rocket. But I think the pattern is still going to be the same, like the whole using environment variables for configuration and all that. So for logging, what we do is, this actually goes to the bigger thing, is that, you know, we have a small team and we want to maintain as little as possible and only do things that are kind of core to our product. So logging, we use an external service called Log Entries that works pretty well for us. And we try to do that with everything. Like even databases we're not managing, I mean, we're just using Amazon's RDS, which is awesome. And using CoreOS and using Docker, it makes it really easy to do all of this because of the way that you manage dependencies. You manage them through configuration environment variables. Like if we wanted to switch from logging to something else, it'd just be a configuration change. That's it, and everything would work fine, assuming it was still using syslog. But you do come up with a few questions. Like we had to ask ourselves. So the CoreOS way of logging, you're supposed to log everything in the container to standard out, and then CoreOS's journald will manage the logs. And then what you can do is listen to journald and export it somewhere else using another Docker container or something like that. But and there's a few other ways that you can do it. Another way, you can use a volume mount. So basically, like volume mount the Docker container's log directory to the containing hosts thing, so that containing host mount somewhere. Or you can also log inside the container, and that's actually what we ended up doing. So in our containers, we'll run supervisor D, and we'll run our application, and we'll run our syslog. One of the reasons that we do that is because it's a lot easier for us. Another one is because I don't know if this is a journald thing or CoreOS or what, or Docker or what, but the lines can only be like 248 bits long, bytes long. So just different options. The cleaner way to do it would be log it to standard out and have Journal D manage it. Is the pizza here?
Not yet.
Holy cow. All right, well, we'll do the app demo. This is the cool part. I'm not going to do that. I'll just expand it. Which one's the plus? That one? No, not that plus. No! I don't even know how to use this.
They changed it in Yosemite.
Oh, is that why? Okay. Stupid Apple. All right, I have 4 tabs open here. One is just my computer. One is a CoreOS 1. One is CoreOS 2. Do you know how to make the text bigger without resizing the window? Yeah, that resizes the window too. Yeah, I know, right?
Command plus.
Command plus. No, that does it too. Whatever. Can you guys see that? Like, I'm kind of having a hard time seeing it. Alright. I should only need the first 2 anyway. Alright, so I have my local host as this first tab, and then just CoreOS running in a virtual box on 3 different virtual boxes for these third ones. You can see what machines are in the cluster really easily using Fleet. Just use list machines, see, so we have a cluster. Whoa! I think we skipped some slides because there's some stuff I didn't talk about. Just a minute. Oh, I guess not. Oh, actually we did. So in Cloud Config, you can also specify some metadata, and you can change it after as well for different machines. So you use things like what availability zone it's in, or what the role for that server is, if it has a specific role or something like that. So one of the machines I added in there, I just added the key value type as load balancer. So nothing else other than that. I basically used the Cloud Config to start these machines that was in the example. And you can see what units are submitted by just using list units. Right now there aren't any. Another thing is etcd. I'll just show that. There's a default one, or there's one in there for the updates. So I just set the key high, switching to another box, and it's there. So that works, that's good. All right, so I made just a dumb hello world. It was written in Python. I switched it to Go just for this. Super basic, listens on port 5000, and has one handler that says the host name. So in Docker, it assigns a random host name by default. So it should just print the random host name. And I made a service file, or a unit file, for that. And this is as simple as it gets. Well, first there's a timeout that sometimes messes you up, because when you Docker pull, sometimes if it's a big image, it can take a while. And other than that, it just runs the image. Oh, so do you guys know what like the Docker registry is? how you can push images to that. All right, some people are shaking their heads, so I'll show you. So you know, like Git repositories, right? Like GitHub, how you can push to a Docker repository, and then you can pull that same image down. So Docker kind of works in layers. So it will push all the different layers if they don't exist, and all that stuff. It makes it really nice. I'll just build it for kicks. So this hello world. So what we're doing is I'll show you the Docker file after, but this is building a Docker image, tagging it as rock climber, which is my username / hello world. And all it does is it adds the built binary to the root directory / app, exposes the port 5000, and says to run that by default. So oh, and I also use an image as the base called Alpine. It's kind of turning into a pretty widely used image because it's super small. Like as you can see there, it's only 5 megabytes versus using Ubuntu, it's going to be like 350 megabytes. So it makes it a lot easier to deploy. And Go is, yeah, I'll just say this now. Like Go is turning into kind of a big deal for these as well because you compile static binaries. You don't have to pull all these different dependencies. It can make for super small images. So if we run this image, then that should expose it on the, oh, I need to find it. So what we're saying is the Docker container port 5000, right? We expose port 5000 because that's what that hello world service was actually bound to. We're binding that to the host or my laptops or my VirtualBox's container 5000. I guess it's we're using VirtualBox. And so we should be able to browse to that. I don't know what host it is though. I can't read that. No. Whatever. We'll skip that. So it's running, right? I'll show you when we get to the other part. Oh, I know what I can do. Right here in the list machines. Does anyone see my mouse? Okay. All right, it's that first one. There it is. So 6, that's the host name of the box. Oh, and just so you know, so I was saying that Docker was a client and a server. All I did was just exported the environment variable Docker host to my VirtualBox machine, my CoreOS machine, and then all of my Docker commands work from my laptop to that. All right, so that's working. Now we just need to make it work with Fleet, and to do that, we make the service file, which I already showed you. It just runs our same Docker command that I ran on the command line, and what we need to do is submit that to the cluster. All right, so when you submit it, it's looking for. Oh shoot, that's not good. Oh, it's because this also needs a. So fleet, you can use a tunnel to just use a SSH tunnel. And I did this before, so I need to remove that. All right, so when we run fleet control list units, it's actually not going to show anything because all we did was we submitted it, but the scheduler hasn't actually loaded it or assigned it to a machine to be run. And so to do that, we load hello world.service. And this is actually like a name, it's not the file name. So I don't even need to be in this directory, that file doesn't exist because we already submitted it to the cluster. So the cluster already knows about it. We just say load it and assign it to a computer. And so there it is. It assigned it to the third CoreOS machine. So now when we do list units, it should be there. It's inactive. It hasn't started yet. So all we need to do is just say start it. And it's going to take a minute to download. So while it's downloading, let's move on to the next thing. So you remember those systemd specifiers that you can use? Well, they're based off, or a lot of them are based off the name. 2 of them are. So that's good for creating multiple instances of the same thing. If we try and start this hello world.service again, it's not going to do anything because there's only one name. Oh, and it started. So this @ in a file name means something special for Fleet. And basically anything after the @ but before the service gets set into a specifier that's %I think. The one before as well is set to something. It has a special meaning, but for now we'll just focus on the other. If we submit the hello world this @.service, it'll break CoreOS, so don't do it. But look, there's just a couple small changes in this one. The first one is we set the name to hello world -%I. So anything after the @ but before the service will just get substituted for that %I. So if you say @1, the name of it will be hello world -1. And another thing that we do is, this sleep one is, I don't know why I needed that, I remember I do though. But then we use etcd control to set a key for /hello world 1 with the host name and port of the instance it's running. And we do that to keep track of all the different instances. And same thing here, we just remove that instance as soon as that is stopped. So let's start this. And we'll call it @1.service. All right, it started it on the second one. We have 2 different instances running. One is our just static one, and another one is the distributed one, or the one that we can use those specifiers. But the cool thing about that is that, so we have one starter, but let's say we want to start like 2 or 3 more, or 4 more. We just say start. Oh, so start, what it'll do is it'll submit and load if it hasn't already been submitted and loaded. So it'll submit, load, and start. All right, so now we have 5 different instances, and each one of these should work. But one thing that we didn't do in this service file was bind to a port. We just bind to the IP address, and the port is assigned at random. So if we're on the first CoreOS box, you can see it's just a random port. It's 49154, 49153. So it'll work if we go to it, I hope. Oh, nice. All right. Yeah, see, it'll work if we go to it. But like that doesn't really help us. So we need some kind of load balancing, right? And so this is kind of where etcd does its magic. We put in the key for each one of these boxes. Oops. I can't see this. Can you guys see it? Okay. So it has the hostname and port. So we have all the information we need. We just need to tie it all together. So for that, I just use Nginx. Don't use Nginx in production as a load balancer. But I made a quick image of Nginx using that same Alpine base. We install Nginx curl and bash, install confd. So confd is something written by Kelsey Hightower, CoreOS author, that will generate config files based off etcd keys or entries. And so we'll use that in running this. We make a few config directories, we add some templates, and then we just run this boot.sh script. What boot.sh does is it will set a few, say where etcd is, and it'll run confd every 10 seconds and parse this toml file, and then just start Nginx. So what confd does, or what the toml file is that how you say it, toml? 2ml, whatever. Is it listens to, or it watches etcd keys, and when they change, update, so it'll listen to /app/hello world where we set our stuff, and use the source template for nginx.conf, save it to this file, and it checks to see if the config is valid, because if you don't have valid config, you don't want to actually like restart Nginx. So it just runs Nginx's check command, and if it is good, then it will reload Nginx with the new config values. Because once we change the config with new entries, then we need to restart Nginx or reload Nginx. And the template is basic Nginx load balancer, but this right here is the confd formatted thing. So for each key in /app/hello world/star, we set the server to the value and end. That's the only thing. And so we also need the service file to submit that to the cluster. We use some of the fleet things that I was telling you about. One of them is conflicts with nginx.service, so don't start Nginx on a machine if it already exists. And also we only want to start it on things that have the metadata with type equals load balancer. That way if you have like a DNS entry to a specific IP, you don't want that like randomly throughout the cluster. All right, and it pulls down that image. I don't think there's anything special. Oh yeah, also bound on port 80. Submits it to the right one, to the one that we wanted to. Any questions?
What's the difference between the Hello World Cloud Service and the Hello World Dash dist? Are they the same thing?
Pretty much the same thing, except for that specifier for the one. And another part that was changed about it is that, oh shit. Okay, all right. I'll stop this after this. So the other part was the names. So it just assigns a name of what that one actually is. That way you don't get conflicts. All right, so it started now. So we should be able to go to this host, port 80. And we get a different server each time. So now scaling up is just a matter of launching more CoreOS servers with the same discovery token, and adding more hello worlds.
Cool.
And same thing for scaling down. And ConfD will be constantly looking at etcd to update that config. So, yeah, that's the demo. Pretty cool, huh? Yeah.
In production, what are you using for your load balancer?
Not that.
Well, I wouldn't use that either. But
We're using ELB, Amazon's ELB, and what we actually do is kind of different. We use this presence pattern, and what that is we start another service that runs on the same host as something that's running. So with ELB, you have to, like, ELB only works on one specific port, so you can't actually have like multiple instances on the same box or use random ports, so you actually have to specify the port and only have one instance running on a host. So what we do is we have, I'll show you. We have these presence servers that kind of follow the web servers, so we say run on the same machine that has this service. And what it does is just when it starts up, it'll register with ELB. When it stops, it removes it from ELB.
okay, that's a cool idea.
Yeah. Yeah, and so something that's cool about this is we just have one cluster for dev and production. So if you see here, we have all these dev instances right here, and we can do that because you can constrain the amount of resources using Docker, like saying only use this much CPU or this much RAM or whatever. So we're running dev and production on the same host, which saves money, which is good. All right. Break. I don't have very much more, but let's take a break and eat pizza.
So on EC2, how many, are you just running on a single host then?
No. We have multiple hosts. With CoreOS or with etcd, you really have to have at least 3 because if you have, because of the way the protocol works, if you lose 2 boxes and you only have 1 left, then it like breaks everything. So you want at least 3 just for the restart. Yeah, let's eat some food, and then we'll just do a quick follow-up after. And that's where you have the application and have something listening on that application to register for different things. The one that we use it for is for a load balancer. And here's what a presence server looks like. It looks just like every other thing. You're running a Docker container. But there's one difference, and that's this binds to. And so it'll bind to the web service, the application, and so when that stops, then this will stop and pull it out of the load balancer. There's also the ambassador pattern, and this is where you can do application level load balancing, and this is kind of why Kubernetes is really cool and why we are probably going to be moving to this, because we're kind of doing something like this already. And that's where you have your application and it depends on some other service like Redis. Well, what the ambassador will do is listen to etcd, so you don't have to have that logic in your application. It'll listen to etcd and kind of restart when that changes and just basically point you to whatever server or whatever thing that you need to listen to. So this will run actually on the same physical machine as the application. and have a little bit of logic. And so when I say Kubernetes does that, it has it built in through their controllers, so it automatically load balances. But the ambassador pattern, Google that, it's pretty cool.
So for the ambassador, if you use ambassadors as Docker containers, does that mean you put an ambassador in your container?
No, so the ambassador is its own container.
Okay.
Yeah, so if you've used Docker Link or Docker, the dash link argument, or use Docker Compose, an ambassador would kind of work in this same way as that. So our migration hasn't gone without its issues. One of them I talked about how Docker containers can't be killed with systemd because it's a client, not a server. Another one was CoreOS used to use Btrfs, and we're actually still using it, but by default they've switched to OverlayFS. So they're both copy and write file systems, that work with Docker. But Btrfs, I have an example on the next slide. It's a pain. Another one is big images. So when we first moved on, we had our main application was like 800 megabytes, which was kind of a pain to deploy to our servers. Just took a while. So deploys were, like 15 minutes or so. It just took too long. So we've kind of gotten around that by breaking it apart into more microservices. But you can still run into issues with bigger images, and you're constantly fighting to keep them small. Also compiling. When you create your image, if you compile everything in the image as in your Docker file, then you include like GCC and stuff when you might not actually need GCC in that container. You can get around that by using two different Docker files. So you have one to actually compile the application, and then another one to take the compiled stuff and just put it on another image. And that's actually what I did with the Go example. I had one Docker file that will compile the app. So then all I have to do in the other Docker file is just add the compiled app. So this is the Btrfs problem. So if you run df-h, you have 18 gigabytes free, right? Well, with Btrfs, that's not true. I didn't add it in here, but if you touch a file just to create it, it wouldn't work. It just said no space left on device. So if you use the Btrfs command to actually show what's used, you'd have this. This is the amount used. This is what's available. So it was full. And so to fix that, you have to run this Btrfs rebalance command, and it'll reorganize the bits and bytes. I don't know what it does, but reorganize the bits so that it actually works and cleans up all that space. So supposedly that's fixed in Btrfs 3.1.8, but CoreOS isn't there yet, so I don't know. And actually this is the reason that CoreOS switched from Btrfs to OverlayFS by default. With the 3.1.8 Linux kernel, they include support for OverlayFS, so they're just like, let's do it. So some other things you should look at, I've talked a bit about Kubernetes. It's pretty cool. Deis, they try and make Heroku hosted on CoreOS. It works pretty slick. It's a little bit more management than we want to do for as small of a company as we are, just because the overhead of managing the Deis service added onto our applications was a little more than we wanted to do. But it's still really cool. We actually borrowed a bunch of patterns that they use for ourselves. Look into the Google's EC2 container service, and also Docker Compose. For development, that's killer. That's the first tool you should be working with. So questions?
You gonna post these slides somewhere?
Yeah, sure. I don't know where, but I will.
So what was the use of the discovery thing you had in the first slide?
Which one? The very first slide?
Very, very.
This one?
You know.
Discovery? So,
Yeah.
what discovery?
So there was discovery.io or something?
Oh, yeah. So that's what etcd uses. This one.
Yeah.
Yeah, so when starting a server, the discovery key is it's just a hash. So what you do is in your web browser you can go to this URL and it'll just give you a hash and that's it. And what you do is you just take that hash, or you can do it programmatically or whatever, and put it right here. That's a unique identifier for your cluster. And so you use that same key for every node in your cluster. And what etcd will do is when it starts up, it'll ping that cluster, it'll ping that URL, and it'll just return a list of all the nodes that are currently in the cluster. And it'll talk to one of those nodes in the cluster and say, hey, I want to join you guys. And that negotiation will go on, and then it updates this URL of what's actually in the cluster.
So what if that service is down?
Then you're screwed. Yeah. So they actually recommend to run your own internally, and they have the code to do that as well. We actually use the public one because we're like, whatever. Okay. It hasn't got down yet, and it's only used for introductions, and we're not spinning up in new servers very often. Any other questions? Yeah.
So, on your examples, you were running 3 virtual boxes with CoreOS, and then you deploy your Docker containers on that. Right?
Yep.
How is it on an Amazon instance?
Yeah, that's what we use in production. It's exactly the same. I mean, you start at the exact same. I can reuse the same cloud config and everything. And we have like a 50-line Python script that uses Boto that will register new instances with that cloud config just so we don't lose it. And that's it.
So you would imagine you would spawn some Amazon instance, and you would have one CoreOS VirtualBox running?
No, yes.
Machine?
Yeah, so CoreOS, like if there's an AMI of CoreOS,
Okay.
and so you just
one of those.
Yeah, and it has everything that you need. Actually, it's cool if you just start 20, right? Because you use the same cloud config, just put 20 in, and they all join up. You do list machines, all 20 are there, and it's really easy. Yeah.
You talked about how you wouldn't put Nginx in front of your Docker containers.
Yeah, I've just never used Nginx as a load balancer. I was actually talking to somebody here that does, and he says it works pretty well. Cloudflare, I guess, is using it. Yeah. So maybe I'm wrong. Yeah, we use Amazon's load balancer. Just it's we don't want to manage anything that we don't have to, and it's really easy to do that. So we just use that, and it's cheap. All right. Cool. Well, that's it.